Welcome everybody to today's webinar on the new Gurobi 9.5 release. Okay, so let's dive in. So this is the summary of today's topics. So Gurobi 9.5, of course, as previous releases, always comes with new performance improvements. So that is one of the main things that we are going to talk about. But then we will also have a number of new features that I will explain after this session that I will present on the Gurobi so-called engine, so the algorithms about math programming. I will pass the presentation to Michel, who will then tell you all the nice new things that we have added into the compute server and cluster manager products. Okay, so let's take a look at the performance improvements. So we do have significant performance improvements on all of the problem types that Gurobi supports. You see here this table with the numbers. So concurrent LP has been improved by 14% overall and 55% on the harder models. And similar numbers you can see for the other three algorithms that are able to solve linear programming problems. So primal simplex, dual simplex, and the barrier algorithm. All of them are roughly in the range of 20% improvement overall and 40 to 50% improvement on the harder models. And then what is the most important problem class for most of our users is the mixed integer linear programming, MILP problem class. Here we improved the performance by 15% and on the harder models by 27%. And then we have also some nice improvements on the quadratic problem classes. So convex MIQP, so that means you can have a quadratic objective function, a convex quadratic objective function. And MIQCP means you can also have quadratic constraints, in that case convex quadratic constraints. Those are improved by 30% overall and about 70 to 80% on the harder models. And then since Gurobi 9.0, we also support solving non-convex quadratic problems. And there we have already seen a really large speed up in Gurobi version 9.1. And now with 9.5, we have achieved another really big speed up of a factor of 3 overall and a factor of more than 7 on the harder models of our test set. Okay, but let's look first on MILP. So when you look at the trend, historic trend, starting with the first version 1.1 that was released and it could solve already MILP problems, we have now achieved a more than 70x speed up compared to that very first version of Gurobi. Of course, when you compare runs on such a large time horizon with so many different number of time limit hits, then it's always a question of how you really compare runtimes, because the actual ratio of the runtimes will heavily depend on the time limit that you set. We have found a way, which is called this part 10 way, where we think that is kind of a fair comparison for this historic purposes. So just as a reminder, so the actual numbers that you get here from this comparison heavily depend on the way of how you compare them. But I think that is what we think is kind of reasonable, and this is where the 70x factor comes from. So one particular component that we have added to the MILP performance deals with SOS constraints. So this is just one tiny little thing. And of course, we have added so many individual small improvements that then add up to this 27% overall improvement on the harder models. And the SOS constraint improvement that this is here about is just one of those. So recall that SOS constraints, that means special ordered set constraints, they come in two flavors, so SOS type 1 and SOS type 2. And they deal with a set, an ordered set of variables. These can be continuous variables, integer variables, binary variables, whatever you want. And they state with type 1 that at most one of these variables can be non-zero. So these SOS type 1 constraints you could, for example, use to model so-called indicator constraints. And then SOS 2 constraints, they say that at most two variables can be non-zero. And if there are two non-zeros in the set, then these two variables must be adjacent. So here it is really important that the set is ordered. And this is typically used to model piecewise linear constraints, this SOS2 constraint. So how you can deal with that? Well, you deal with that by branching. So if in an LP solution, you have two variables that have a non-zero value in an SOS1 constraint, then you can just branch on one of the variables, set them to zero in one child node, and set the other set of the variables to zero in the other child node. And by that, you can make sure that in the end, you will find a solution that satisfies the SOS constraints. But another approach for dealing with these SOS constraints is to reformulate the SOS constraint in a MIP model. So in this case, an MILP. So new variables and linear constraints. So one example for such a reformulation is the so-called multiple choice model for SOS1 constraints. Here you see we have introduced new auxiliary variables, binary variables, ZJ, and they basically model that if the ZJ variable is zero, then the corresponding XJ variable must be zero. So this is the purpose of this of these two constraints here, right? So if Z is zero, then of course here is a zero and here is a zero, and then X needs to be forced to be zero. On the other hand, if Z is one, then XJ just can be between its lower bound and its upper bound that has been set. And then the constraint above here that says that at most one variable can be one, and that then models the SOS constraint. Of course, this formulation depends on these bounds that you have for the X variables. And if you don't have bounds, if the X variable has an infinite bound, then you cannot use that model anymore. And if the bound is finite but still very big, then this formulation would really lead to numerical issues, and you also don't want to use that formulation. So, but in addition to this multiple choice model, there are also other encodings proposed in the literature. For example, see this nice paper of Huchet and Bielma from 2018. They consider several different formulations for SOS constraints. So some of them are linear in size, so just like this multiple choice model, right, where for each variable in the set, you introduce one new variable, and in this case, two constraints plus one additional overall constraint. So this is linear in size, and there is another linear size model that is called the incremental model. But then there are also logarithmic size model. So where you just need way fewer variables to represent this. This is typically based on binary array codes. So that means, for example, if you have 1024 variables in your SOS set, then this would only need in the order of 10 additional variables to represent the SOS set as an MILP model. So typically, these encodings all lead to the same LP relaxation value. So in that sense, they are not different, but they differ in their size, of course, and they also differ in the strength within a branch and bound algorithm. So that means what happens to the solution after you branch on one of these variables, in particular on one of these auxiliary variables that you have introduced to model the SOS constraint. So prior versions of Gurobi, so all versions up to version 9.1, are able to automatically reformulate an SOS constraint into the multiple choice formulation. And this is in automatic settings done by looking at the bounds of the corresponding variables. And if all of the bounds of these variables are small enough, controlled by these two parameters, then we would translate an SOS constraint into an MILP formulation. So the reason why we do this is that the MILP formulation will then, of course, appear in the LP relaxation, and then usually the performance will improve because the LP relaxation somehow treats the SOS constraint as well, which is not the case if you only deal with the SOS constraints by branching. With version 9.5, we introduced 3 additional encodings. So the incremental, also linear size encoding, the binary gray code encoding, and the zigzag integer code. The latter 2 with logarithmic size. And the default value of -1 for this parameter here would just select one of these 4 encodings automatically, or also a possibility to keep the SOS constraint as an SOS constraint and don't translate it. Okay, by doing so, we have achieved a 6% performance improvement overall on our SOS test set and 14% improvement on the SOS models that take more than 10 seconds here. So that means in particular, if you have models with piecewise linear constraints where SOS2 plays a big role, then this may help you a lot for solving your models faster. So then let's take a look at this very big speedup that we got for non-convex MI/QCP. Of course, all of the improvements that we do for MI/LP will also usually translate to MI/QCP and non-convex MI/QCP, but there are also some ingredients that are really specific to quadratic and in particular to non-convex quadratic programming. And one of those is the new heuristic that we have added, which is one reason why we now see this additional nice speedup here. And if you look at the historic comparison, of course, this is not that interesting right now because we only had 2 versions that were able to solve non-convex quadratic problems, version 9.0 and 9.1. And here you see the performance plot for those in the same way of comparing historic versions that we used for MI/LP. Then you see there is a really nice speed up in version 9.1 already. This is about a 9 times speed up in this metric here. And we have another, in this metric, another, what is it, like 8 to 9 speed up in version 9.5, which gives a total of a factor of almost 80 compared to version 9.0 on this test set. So, but I have to say this test set is just a few hundred models, so 400, 500 models or so, while for MI/LP we have a test set that is 10 times as large, so more than 5,000 models. So the results here are a little bit have to be taken with a little bit grain of salt. Okay, but back to this heuristic that I was talking about. So the point is that for many non-convex problems, it is very hard to find feasible solutions. So in particular, if the model contains non-convex quadratic equations with continuous variables, because then the outer approximation given by the McCormick relaxations, any point in this outer approximation will, of course, never be feasible, right? Because the quadratic equation will always be inside that McCormick polytope. So with the LP relaxation, we will not be able to find a feasible solution that is really directly on the surface of the quadratic equation. So the only thing that we can do here is we need to branch on these continuous variables until the domains of the continuous variables are so tiny that we can consider that this point is close enough to the surface of the quadratic equation. And then we just say, okay, that's feasible. And then that means we need to dive really deep into the trees, so very deep nodes you will then see until we find this feasible solution. So a lot of branching needs to be done to find a feasible solution. So with Gurobi 9.5, we have added this NLP heuristic that is based on a nonlinear interior point algorithm. So what is this doing? First, of course, it needs to treat the integer variable, so it will just apply a relatively simple fix and propagate scheme to fix all the integer variables to some values. And then the remaining problem is a purely continuous problem, of course, typically still non-convex. And then for that continuous problem, we call our new nonlinear interior point algorithm, and that will then find, hopefully, a feasible local optimum. So it is not able to find a global optimum. For that, you need branching, but it is hopefully able to find a feasible point, which will then be a local optimal solution. So this algorithm uses a parallel direct sparse LDL transpose linear system solver that we had to implement. It has quadratic local convergence, and there are already some heuristics included that help to achieve global convergence. So global convergence does not mean global optimality. It just means that independent of the starting point that you use for that algorithm, it will always converge to some local optimal solution. So this is where these heuristics kick in to help to achieve that. Of course, it can still fail to do so. But essentially, the algorithm is, you can view that is what IPOpt implements, but really restricted to its skeleton. So IPOpt has many more fancy bells and whistles that we do not yet have, and which we will, of course, add in the future to improve that algorithm even further. But for the quadratic problems that we deal with, so IPOpt can deal with general nonlinear programs. For the quadratic problems that Gurobi can deal with, this nonlinear point algorithm already works very well. So which you can see here in this performance results. So when you look at our test set and measure the improvement due to that heuristic for time to optimality, then you see overall a 19% speed up and a 41% speed up on the harder models. Okay, it is probably not that great, given that this is a completely new algorithm that we had to implement, and this took us about almost a year to implement that algorithm. But the point is that it is really helping to quickly find feasible solutions much earlier. So if you look at the last row here, finding the first feasible solution, that is already almost twice as fast as without this heuristic. And if you only look at the harder models, then it's even better. So this will often give you a solution already at the root node when Gurobi 9.1 has failed to produce a feasible solution. And overall, on our test set, the number of models where we are not able to find any feasible solutions also reduced, in this case from 79 to 60. Okay, that is what I wanted to say about performance. So let's look at the features. So one feature that we have added, and like many of the features that we will go through were requested by users, is the ability to combine LP warm start information with pre-solve. So recall that you have as a user two options to specify an LP warm start. The first option is you specify a pair of primal and dual solution vectors. So that would be through the P start and D start attributes. And the other option is you provide a basis. So this is this combinatorial object where you say that a variable is non-basic or basic and that a constraint is non-basic or basic. And this you provide through the V basis and C basis attributes. So, if you solve an LP without providing warm start information, then the final basis that Gurobi finds will be stored internally. And then when you modify an LP, then Gurobi will start from that basis that it has stored. So you don't need to fiddle around with these P start, D start, or V basis, C basis attributes. So Gurobi will do that internally. But then in previous version, what will always happen, if you solve an LP and then modify it and then, for example, add another constraint or change a bound and then solve it and then resolve this problem, then what we would do is what is here listed as the option 1 of this new LP warm start parameter, which namely means that if there is a warm start, then we would disable pre-solve. Because we want to start from that basis and then just continue, and we would do that in the original problem formulation. And if you set both P start and D start and V basis and C basis, then this procedure would prefer the basis over the start vectors, because the basis, that is the combinatorial object that the simplex algorithm needs, and which can directly start from that. On the other hand, you can now set this parameter to 0 and 2. So 0 just means you completely ignore the warm start information. So it would apply pre-solve, just like starting it from scratch. So of course, you could already do that by discarding the P start, D start, and V basis, C basis attributes. Now you can set this parameter to 0, which is a bit more convenient for you. But the actual new thing here is this setting of 2. so that will apply pre-solve and then try to still benefit from these start vectors. So here, for that setting, it is actually slightly easier for us to use the start vectors, so the p start and d start attributes, because these vectors, those are the ones that we are able to crush through the pre-solve and translate them into corresponding start vectors for the pre-solved model. We are not able to crush a basis through our pre-solve. So that means if you only provide a basis, then what we do is we apply pre-solve, but first, before we apply pre-solve, we would first construct these p start and d start vectors that we then need by applying the simplex algorithm with a 0 iteration limit. And of course, that means we just compute these start vectors from the basis. And now we apply pre-solve and then crush these start vectors through pre-solve to have corresponding start vectors for the pre-solved model. And then we would use those to warm start the pre-solved model solve. So which means that there is a kind of a crossover step to try to construct a basis from these start vectors first and then start from that constructed basis. Okay, that is what I wanted to say about the warm start with the LP. Now, another feature that we have added is that we are now able to support norm constraints by means of our general constraints mechanism. So in Python, this could look as follows. So you have a vector of variables x, in this case, 10 variables, and you have a single variable y, and then you can add the constraint that y should be equal to the norm of the vector x. And now we have 4 choices for the norm, namely 0, 1, 2, and infinity. So the 0 means the 0 pseudonorm. So that means that y should be equal to the number of non-zero entries in that variable vector x. And here you can already see some kind of a numerical trouble arising, because what should y be if there is an xj variable that is equal to 10 to the minus 6, for example? So should that be counted as a 1, or should that be counted as a 0 for the counting of the number of non-zeros? So this is kind of difficult. For that reason, you have to be careful with that if those situations arise. Internally, we would use here a threshold of 10 to the minus 3 to do that, but this is really gets a little fishy. So one direction of that constraint has kind of numerical trouble that you need to be aware of, right? So if you only say y should be, so what is it? Larger or equal to the norm of x, I think then that's okay, and the other direction could be problematic. Okay, then n equals 1, that is a sum norm, so this is just the sum of the absolute values of the variables. So of course that is boring if the variables are already non-negative. In that case, this is just equal to the sum, a linear constraint. But if the variables can also be negative, then this really makes sense to use the 1 norm constraint. Then the 2 norm constraint, that's the Euclidean norm. That, of course, then leads to a quadratic constraint if you use that. And here again, you have to be aware of the fact that if it's really an equation, then this corresponding quadratic constraint is non-convex. And you need to set the non-convex parameter to 2 to be able to solve that problem. You always model that as an equation, but Gurobi is able to easily find out that you actually only need one direction if the y variable is used only in a particular way in your model. So in this case, if you really just need y is larger or equal to the Euclidean norm of the vector x, then the problem stays convex, and Gurobi will automatically identify that. So for example, if you want to minimize the Euclidean norm of such a vector, then you would minimize y and say y is equal to the norm, but Gurobi will automatically find out that it suffices to state that y is larger or equal to the norm, because the minimization of y will already make sure that y is then equal to the norm. And by that, we have an argument that the problem is still convex. So and then the last one, infinity norm, that's the maximum norm. So this is just the maximum of the absolute values of the variables. Okay, so another thing that we have added is the deterministic work measure. So when you are dealing with wall clock runtime of an optimization, then of course you know that this wall clock will be non-deterministic, right? So that means if you have two runs, both runs use the exact same problem data, the exact same parameter values, and you run it on the same machine, same hardware, then still these two runs will probably have slightly different runtime in the end. That is maybe not so bad, but if you combine that with a time limit parameter, that has the consequence that if there is something significant happening right about the time limit, like finding a new solution, then the resulting output of Gurobi can be non-deterministic, right? So if you have a time limit of 10 seconds and Gurobi in the first run finds a solution after 9.9 seconds, then in this first run, you will see that solution as the final solution that Gurobi provides. But if you run it a second time, where this solution would only be found at 10.1 seconds, but unfortunately the time limit kicks in at 10 seconds, then the final solution that you will get will be a different one. So here the results will be non-deterministic if you use wall clock runtime. So in order to give you some tool to deal with that, so if you really need deterministic abort criteria, then you can use the new work attribute and the new work limit parameter to do that. So what does that mean? So it means, of course, the opposite of what the time limit parameter is doing. So that means if you have two runs with the exactly same data, same parameters, and running it on the same machine, then this optimization run will always result in the same amount of work. So, and this is also true for parallel execution. So if you use parallel algorithms like the default MIP algorithm. And as a consequence, if you set the work limit parameter, this will then lead to deterministic results. So two runs will always have the same result, exactly the same result. So what is this work attribute here? So you see that here in this log file, it is displayed like the usual at the end. You say that it has explored 3,255 nodes. This was on my machine, and this was solving the AFlow30A model from the MIP. It took 1.18 seconds, and it also now says it took 0.96 work units. So what is this work unit? So this is just a deterministic measure that we have tuned to be roughly 1 second on our hardware that we are using for our tests. So if you have a faster machine than we do, then of course you would consume for the same optimization smaller number of seconds, but still the same amount of work units. So that means your ratio of work units per second is then larger. But it does not only depend on the machine, it also depends on the model. So on the model class, on the model size, and also on the algorithm that you're using. So it could very well be that if you solve an LP with the barrier algorithm, then the work units by second ratio is different than when you use it with the simplex algorithm. So that is a challenge for us because it has just so different properties, algorithmic properties in particular when it comes to memory access. So, but if you're using always the same algorithm and you're operating on the same class of models that have roughly the same size, then the work time ratio should be roughly stable. So what you can do, you should experiment with your models on your hardware and then just see, maybe you want to have a 10-minute time limit and then just run a few models and see what does it mean in terms of the work units, and then you specify your work limit parameter according to what you have observed on your models. Okay, another parameter that you can control to limit the solve is the newly introduced memory limit parameter. So this is simple, right? You just set the mem limit parameter, for example, to 1.5, which means that Gurobi is allowed to use at most 1.5 gigabytes of memory. And if it needs to allocate more, then it would just return you with an out of memory error. But there's one catch with that parameter, namely, you can only set that in the master environment before you start the environment. So you need to set it at the very beginning. Here, in this Python code, you can do this like that. Here, right? You set this dictionary of parameters P. One of those parameters would be the mem limit parameter, and then you instantiate this environment. So you call the constructor of the end class with params equals P, and then that would make sure that the environment gets created, and then the parameter would be set, and then the environment would be started. So that is then feasible. But you cannot change the parameter anymore after it has been started. And the reason is that when this memory limit parameter is active, then Gurobi would internally track and count all the memory allocations and memory frees that we do, which means that if you were able to set that parameter only after some time, that then the memory allocations that have been happened before that point would not be tracked in this counter, but the memory would then at some point be freed, and so the counter would get confused, right? So that is the reason why you need to set the memory limit parameter right in the beginning. Okay, just one note: if you set the memory limit parameter, then the abort due to that memory limit can be non-deterministic in parallel algorithms, just like the regular thing when the operating system tells us that the job ran out of memory. This is, of course, also non-deterministic. We have added some user control to the solution pool, also a feature request by our users. And this is the following. So recall that the solution pool stores a set of solutions that we have encountered during the MIP search. So you can even set the pool search mode parameter to 1 or even to 2 to continue to populate that solution pool with additional solutions even after you have found an optimal solution and have proven that optimality for that solution. And you would use that if you are interested in additional solutions. So often in modeling, the model is not exactly precise for your real-world application. So maybe there are some additional constraints that you don't know how to model that with linear constraints. So, and for that reason, it often makes sense to have a set of different solutions that then the practitioner can look at and then decide which is actually the one that you want to use in practice. So, and now with these new pool ignore attributes that we have added, you have a way to control which solutions end up in this final solution pool. So namely, this pool ignore attribute is an attribute that exists for every variable in the problem. And if you set that for a particular variable to 1, it means that in these identity checks to compare two solutions in the solution pool, these variables get ignored. So that means if we already have a solution that only differs from this new solution in the values of these variables that have been marked to be ignored, then we would say, sorry, we already know that solution, we discard the other one. So and why would you use this? Well, the typical use case is that in your model of your real-world problem, you have introduced a set of auxiliary variables that you're actually not interested in. These are just helper variables that you need to create a linear model for some nonlinear constraints. So for example, if you have an indicator constraint, then you typically introduce an auxiliary binary variable to control that indicator constraint, but in the final solution, you are not interested in that binary variable. You are only interested in the main decision variables. And for that reason, you are also not interested in a second solution that only differs in that auxiliary variables, but on the main decision variables, it's the same. So then you would set the pool ignore flag for that additional variable to 1. So IIS, so that is stands for irreducible independent infeasible subset. And this is a way to analyze infeasible problems, which we have already since, I don't know, version 1, maybe even. And this is, and now we have added a way to manipulate the algorithm to search for this IIS. So you have a problem that is infeasible. Now you call compute IIS, and that should find you an irreducible infeasible subsystem. And of course, what you want to do with that is you want to look at it manually usually, and then maybe you will find out what the problem is. So for example, it could be that you have an error in your model, in your mathematical model formulation that you can then find by looking at the small infeasible subsystem. Or it could be that you have an error in your data that is then revealed by that. Or it could be that this is actually a legitimate infeasibility that will then tell you something about your application, why in this particular case it's infeasible. So now we have introduced new attributes, namely these IIS force flags that you can set. So for each of the bounds, lower bound, upper bound, you have such a force flag, and for each constraint, you can set this force flag. The default value of -1 is just the usual thing. So Gurobi should find out by trying it inside the IIS algorithm whether this constraint or bound needs to be part of the infeasible subsystem or whether it can be removed so that the subsystem is still infeasible. But you can also set it to 0 and to 1, which means to state in advance that this particular bound or constraint should not be in the final IIS, or that the particular bound or constraint should be in the final IIS. Of course, that has some implications here. Namely, if you specify a constraint to be forced out of the IIS, so set this to 0, but this constraint is actually really required to trigger that infeasibility, then the remaining model might be feasible, and then the IIS algorithm would tell you, sorry, your problem is not infeasible. On the other hand, if you set the force flag to 1, then of course the result will be that this final IIS that Gurobi gives you may not actually be irreducible, because it could then still be that those constraints that you have labeled with IIS force equals 1 can still be removed without losing infeasibility. But the point here is that then the algorithm may behave much faster. So here's a typical use case. So you have a base model, which you know is feasible. So this is the base model that you know that you use all the time. You know this must be feasible. But then there is, in order to define your particular scenario that you want to solve for that problem class, you are adding another set of constraints and maybe another set of variables. You may tighten right-hand side values and bounds and so forth. And then with these additions, the problem becomes infeasible. And now what you are interested in is actually only why the base model got infeasible. So which of these additions were responsible for making the model infeasible? And in this case, what you would do is you would set everything that belongs to the base model. You would set the IIS force flag to 1, so that Gurobi does not need to find out whether these constraints and bounds are part of an irreducible set. So, and that means the compute IIS will then typically run much faster. And then, of course, as a user, you would just, when looking at the IIS, you would just ignore the base constraints and base variables and only look at the additional constraints and variables. Okay, we have added some callback enhancements. So now using callbacks is a little bit more powerful than before. So one thing is, which we have had many user requests for, is to lift this inconvenience that you can only provide new solutions from your callback if this was called with the where flag equals to mid node. So now you can also pass solutions from the mid and the mid sol callback. So for example, if you are using lazy constraints that are separated by a callback, Gurobi gives you an integer feasible solution, at least which Gurobi thinks it is integer feasible. And then your callback says, sorry, that is not feasible because here this and this lazy constraint is violated. But then it could be that your callback has a way to turn that infeasible solution into an actual feasible solution. And now you can just provide that solution directly to Gurobi. Previously, you would have needed to store it somewhere where in your own data structures and wait for the next invocation of your callback with where equals with node, and only then you could have passed it to Gurobi. So this is now easier. We have added callbacks to the no-rel heuristic. So now inside the no-rel heuristic, we also call the callback. And for every solution that the no-rel heuristic finds, we will also call a callback, so that makes no-rel compatible with lazy constraints. So, and moreover, you can also now, with the new proceed function from the callback, tell the no-rel heuristic that it should stop and that the solve should proceed with the next phase of the solving process, which will, in the no-rel case, will be the initial root LP relaxation, solve and then branch and boundary. So in order to know whether you are in the no-rel heuristic, you can query the new phase query code, so which tells you whether the solve is currently inside the no-rel heuristic, inside the regular tree search, or inside the improvement phase that you would have enabled with the improve start node or improve start time parameters. Another thing that users have requested was to be able to query the number of open scenarios in a multi-scenario solve, right? So if you have a problem with multiple scenarios, then you may be interested in the number of scenarios for which Gurobi was not yet able to find an optimal solution and prove its optimality. So this is also displayed in the log file, this number. So now you can also query it programmatically inside your callback. And then for the IIS computation that we have talked before about, now we are also calling callbacks there. And there we have added query codes that allow you to query the information that we also present in the log file, which is the bounds on the size of the final IIS. So the minimum number of constraints, maximum number of constraints, the same for the bounds. And you can also query our guess about the size of the final IIS. This is the feature that we have added with Gurobi 9.1. So now you can also query that through the callback. Okay, I skipped the additional attributes part here and will now move on to our enhancements in Gurobi Pi. So first important enhancement is that we are now supporting the newest version Python 3.10. And when you install Gurobi Pi through pip install and just say pip install Gurobi Pi, then it will only install Gurobi Pi without any external dependencies. So if you want to use the matrix-friendly API inside Gurobi Pi, so that is using NumPy and SciPy vectors and matrices, then of course you need to install NumPy and SciPy. This you can do manually as before, but you can now also say directly in the pip install command by providing this in brackets matrix API here that NumPy and SciPy should be automatically installed for you if this is requested. So this could be convenient if you, for example, if you are creating Docker containers where you have these requirements in the Docker file. So in terms of the API, we are trying to more and more get closer to the syntax and semantics of NumPy and SciPy arrays and matrices. And one step in that direction is now that the selection of elements now behaves just like in NumPy and D arrays. So if you have an array class, for example, you call this addVars function to add 10 variables, this will return you a vector of variables. So X will be a so-called mvar object. And if you select one particular variable now, so with X of 3, for example, this will now return you a var object, which is what a NumPy and D array would also do. And previously, in previous versions, that was still an mvar object of shape 1, comma. So now this behaves more similarly to ND arrays. So the tuning tool. The tuning tool is there to automatically find for you a combination of parameters that works good to be on your problem instances. So the goal is to find parameter settings that reduce the runtime typically on your set of parameter instances. So you give a set of models, and then the tuning tool will just try a various number of parameter sets, and in the end, after a very long time, it will tell you which parameters it has found that work well in your problem class. And that would then be the parameter settings that you should use also on new instances of that problem class. So there are a number of new parameters to control the tuning tool. So the first one is the tune metric. So typically what the tuning tool would do, and this is what it would do in older versions, it would try to find parameters that give you the best average runtime over your set of models. But now you can also set the tune metric to a different value so that it would actually try to find parameters that would give you the best worst case performance. So that would minimize the maximum time used to solve your models. So that would be a way where you want to hedge against bad cases. If you have several models of different difficulty, then probably you're more interested in reducing the runtime for the tougher models, and then you can use that. And then there are two additional parameters, tune target time and tune target mid gap. So the tune target time means if you set that, for example, to 5 seconds, and the tuning tool has now found a solution, a parameter combination that is able to solve your problems on average in 5 seconds or smaller, then it would just stop the tuning process, because it then says, yeah, I'm good enough. So if you are not interested in further improvements, so like whether it's 3 seconds, 2 seconds, or 5 seconds, you don't care, then you would set that to 5 seconds so that the tuning tool can stop earlier with its parameter space evaluation. And the same for the tune target mid gap when you're operating on models that you are not able to solve within the time limit that you provide. Then you are mostly interested in the final mid gap, and then you can set that, for example, to 5% if you say something, yeah, as soon as I have found parameter settings that reduce my mid gap to 5% for my models, then I'm fine with that. You don't need to search further. So and finally, I'd like to say a few words about our Mac port. So this is something that we have already introduced with Gurobi version 9.1.2, namely this universal 2 port for Mac. So with 9.1.2, we have treated this kind of as an experimental port, but now with 9.5, this is our Mac port. So the old Mac 64 port is no longer provided because the universal 2 port can deal with everything that you want. So Macs now come with 2 different CPU types. So the old Macs were all based on x64 architecture, so this would be Intel or AMD chips. But the newer ones and more powerful ones that are actually based on Apple silicon, so in particular the current Apple M1 chip. And these 2 types of CPUs have different machine instructions. So that means that the binary code to run on such a chip needs to be different. And the Universal 2 is Apple's approach to include both instruction sets in a single binary. And then the operating system will automatically select the right code path depending on the CPU that you have installed in your hardware. So that means the Gurobi Mac port now contains both the x64 and the Apple silicon instruction sets, and it's just running automatically with the right instruction set on your machine. So this is now supported on macOS starting with version 10.14. Good, and that is the end of my presentation.
Yeah, so I will continue the presentation, and I will cover the enhancement that we have done in Gurobi 9.5 about the platform. First, I will go through what we have improved in the compute server and the cluster manager. At a high level, it's mainly about account management. We have also added integration with the LDAP repositories for centralized user management. We have improved the API key management to integrate and authenticate applications. We have improved the usability of our web user interface, and we have added more options for the database. Next, I will cover how to use Gurobi on containerized environments. I will talk about the new predefined image that we provide on Docker Hub. I will also explain how the new web license service works to license Gurobi inside your containers. And I will go through where to get more information and best practices for deployment. I will finish with a demo of the major features. Before going into the details of the new features, I'd like to explain the current architecture of the compute server and the cluster manager. So compute server and cluster manager is a way to offload optimization tasks to one or more servers that are grouped together to form a cluster. So in the diagram that I'm showing right now, on the right, you have a set of compute server nodes that are grouped together to form a cluster. And the cluster supports queuing and load balancing of the different requests and job optimization. In front of that, you have the cluster manager. The cluster manager is in charge of the security with authentication, authorization. It also provides a web user interface, and it provides APIs to let the client access. The cluster manager has also a database where the cluster manager stores account information, past jobs, history, job metadata, and so on. So this can be used in several use cases. The first is that you have a team and you want to share the optimization resources. You can also deploy the compute server on dedicated machines that are much more powerful than, let's say, laptops, and that can be used directly by the clients. You may also want to ensure high availability of your solution by using multiple nodes. And also this enables you to build modern applications where you have different layers and where you have your application layer connecting to the cluster manager and optimization layer. So the cluster manager that we have introduced in the version 9 has features for the IT and for the OR developers. So for the IT, it's about the architecture with the modern and scalable architecture. It's about security with authentication, authorization, account management, and so on. And also a web user interface to manage the cluster. For the OR developers, it's about monitoring your jobs. So you can have a look at what's running. You can look at the logs of your jobs. You can look at the past history of your jobs. And also you have another way of submitting optimization jobs that have been introduced since the version 9, which is batch optimization. With batch optimization, you can build a model, submit your model, and disconnect. Then it will be optimized in the background. And when the solution is available, then you can reconnect and retrieve the solution. So at a high level, Cluster Manager and Compute Server facilitate the deployment and use of optimization services on-premise or on private cloud. Now let's look at the new features that we have added in the 9.5. So when you use a Cluster Manager, you have a system administrator who is in charge of creating and deleting accounts, managing all the accounts, assigning roles, set and reset the initial password, and so on. We have added one features about enabling and disabling an account. So you can disable an account temporarily and re-enable it later. In terms of user roles, you have, of course, the system administrators, but you have different roles, standard roles and admin roles. The admin can do anything that the standard user can do, but it can also kill any jobs running in the system, can also access the licenses and so on. We have added something new in the 9.5 that was requested by our customers, is a read-only role. The read-only role is used to monitor the cluster only. You cannot submit any job. You just have access to the history and the logs and so on. Also note that when you install the cluster manager, it comes with default users, Gurobi, admin, and sysadmin, with default passwords. And of course, this is to simplify the installation and the testing. But before deploying the solution, please remove those users. We have also improved the authentication. So we support two types of authentication. One with the that we call interactive login for users with a username and password, and we also have API keys for applications. API keys can be embedded into your code and safely used, and you can revoke the API keys easily. So this is really the way to integrate an application. Before you had access to those two types of authentication at the same time. Now we have separated them. So you can define an account for monitoring purpose only that will use the interactive login only, and this account will not be able to create API keys. You can also create a system account. The system account will only use API keys. It will not be able to log in into the system. And a typical other use case, of course, is a developer who can do both by logging into the system, but also having different applications running with API keys. With that comes new features or new actions for the system administrator. It can set the initial authentication type, and the authentication type can be changed at any time later on. Next feature that we have added in 9.5 is a password policy. This is also something that was requested by our customers, and you can now secure the access to the cluster manager. You can define the length of the password, the complexity of the password with the different types of characters and digits and symbols, and you can define a lockout behavior as well. And the system administrator is able to change that policy that will apply to new passwords, and can also reset the password of accounts that have been locked. One of the major addition to the 9.5 for the cluster manager is the integration with LDAP servers. So an LDAP server is a way to centralize the user management. This is where your organization creates users, groups, and define the authentication. Now you can connect the cluster manager to that server. And this brings a lot of benefits because you can now centrally define who has access to the cluster manager and your optimization cluster. And you don't need to create accounts manually inside the cluster manager. As soon as you are somebody that is using the LDAP server is authenticated, then the cluster manager will create the accounts, and there is nothing to do. In addition to all that, the accounts are synchronized, which means that if a user is no longer part of the group that has been mapped and granted access to the cluster manager, it will be disabled, and this account will not be able to use the resources anymore. There are two things that should be noted here: is that the system administrators and the system users, or the accounts that are using API keys only, are not mapped to the LDAP, and this is done because we don't want to have we don't want that any issue with LDAP communication or LDAP integration impact the existing applications that are running using the cluster manager. So let's look a little bit more into the details of the LDAP integration. We have now a new settings page inside the cluster manager, and you can define the integration using different steps, or several steps, so 3 steps actually. So the first thing is that you have to define the connection to your server. You can specify the hostname, the port, and so on. You can also use the LDAP secure communication. And once you have defined that, you can test, make sure that this is working. Then you can define the filter and the mapping of users. So when you map, when you integrate with the LDAP, you have to define what are the users that will be granted access, and that's a group mapping. And also you have to map the different attributes to identify the name, the first name, the last name, and the email of each account. And then you can test again. And then you can deploy that if everything is fine. You can also specify how the synchronization is done, or how often the synchronization with the LDAP will be performed. I mentioned briefly that we have improved the API keys. So an API key is made of an authentication token and a secret key. And each user can manage their own API keys. They can create API keys. They can delete API keys, and this is the way that we recommend to integrate and authenticate applications. We have improved the features of the API keys in the version 9.5. First of all, when you create a new API key, you have a button, a download, that will automatically download your client license file. So the client license file is a license file that contains only connection parameters, such as the URL of the cluster manager and how you authenticate. So this client license file will contain the API key and the API secret. In previous version, you had to create this file manually and cut and paste the different values. This time, you can just download that file and you are up and running in no time. In addition, we have added a few attributes to the API keys. So you can now define an application name and a description. So if you have different applications, you can better track the usage of those API keys. We have also added the last timestamp and the last IP used by this API key. So the cluster manager will keep track of that for you, and you can know if an API key is used and when. And we have added a new feature where you can disable and enable the API keys. This is really convenient when you want to rotate your API keys. So you can first disable it and make sure that it's not being used anymore, and before deleting it. In terms of usability, we have added a few more things. So first of all, we have improved how we do the filtering. And so in this example that I'm showing to you in these screenshots, you have the list of jobs that are completed in a cluster. And you can see that I'm filtering a specific application called Workforce. And this selection is also a part of the URL that you can see at the top of my browser. So, and this is called a permalink. And this is very convenient because you can cut and paste this and share that with other users. And you can, let's say there is an issue or something you want to discuss, you can give that to somebody else and they will access the same information. When you run an optimization job, you have access to the job dashboard. The job dashboard is a place where you can access the log, and the log is updated live while the optimization job is running. And you can also access the job details about the information, the client information, the model information, the parameters, and so on. And we have added a new tile about the metrics. And you can see that we have charts about the objective and the gap that will be updated live while the job is running. So this is something we add in our Instant Cloud product for a while, and we have added that here in the Cluster Manager. We have also embedded our user manual, so it's now easier to understand the different options that you have in the Cluster Manager. You can access the different sections, the different, we'll have an explanation of the different actions, different buttons, all the tables, and so on. You also have access to the release notes. And in addition to that, we have added contextual help links from the different panels in the web UI. So if you have if you want to know more about a given section, click on this question mark icon, and this will open up the user manual at the right page. As far as database management, there are two things that we have added. First of all, we are providing support for the Amazon Document DB 4.0 that is available on Amazon. So globally speaking, the Cluster Manager is compatible with MongoDB, and Document DB on Amazon is a compatible database to MongoDB, and we have made sure that everything is running fine in this environment. So if you want to deploy the Cluster Manager and the compute server on Amazon, you have one more option to consider, which is pretty easy because you have everything available on Amazon already. We also worked on schema migration. For when you install the 9.5 and let's say you had a 9.1.2 installed, all the schema changes will be applied automatically. Those are very minor changes, but in the future, if we have more advanced change to the database, then you will be able to monitor that. You will be able to manually apply those changes with the separate commands. But this time it is a very easy upgrade, and this will be done automatically when you start your cluster manager. Now let's review how we can run and better support Gurobi on containerized environments. So as you know, containerized environments are more and more popular. It is a very convenient way to build and deploy your applications in many environments, QA, staging, production. You can decompose your application into many different microservices, and there are a lot of solutions to deploy your containers locally on your laptops, but also on cloud solutions on Amazon, Azure, and Google, and so on. So to support that, the first thing we have done is to provide predefined images on Docker Hub. We have different types of images. First, about the engine. So we have the Gurobi Optimizer, which is the full optimizer distribution. We have the Gurobi Python image that will contain only the Gurobi Py API for Python. And new in 9.5, we have added images for different versions of Python, 3.7, 3.8, 3.9, and 3.10. We also have images for the compute server and the cluster manager. And we have additional examples that you can take a look at. So if you go on Docker Hub, we have a Gurobi organization. And under this organization, you will be able to access all the images. Each image has a pretty complete documentation, and I encourage you to take a look at that. It will explain how to use the image in different contexts. You can use this image locally on your laptop. You can use Docker Compose, or you can deploy on to a Kubernetes cluster. We provide also examples of scripts to deploy in all these environments. Next is that we are providing now a new licensing technology that is called a web license service. And as you understand, Docker and containerized environments are pretty dynamic. You have containers starting, stopping, and so on. And to support that, we are again providing this new technology. So you have nothing to install. We have servers running in several regions worldwide, and they will activate the use of Gurobi in your containers. To manage your licenses, you can access the license.gurobi.com URL. There you will access the license manager. Academic can create licenses for free, and you can request evaluation. You can also contact our sales for a commercial subscription. We support different platforms, globally speaking, but we have looked at more specifically at platforms on Amazon, such as EKS using Kubernetes, ECS, and Amazon Batch. On Azure, we have AKS, Container Instance and Batch. On Google Cloud, we have the Google Kubernetes Engine, and also Red Hat OpenShift. So in all these environments, you will be able to use our new licensing service. Let me give you some more details about how this works. So we have servers, as I was saying, deployed in 5 regions across the world. And when you start a container, it will automatically connect to the closest servers that we have, and it will dynamically activate the use of Gurobi in this container and check that you are entitled to use Gurobi in this environment. Typically, it will also check how many concurrent containers that you are launching at the same time, and this can be used with the Gurobi library, or it can be also used with the compute server and cluster manager. Also, to give you a better sense of how all this can be put together, we have developed demos. I mean, we have had these demos for a few years now, and we have deployed all those demos into Kubernetes clusters, a cluster using all the latest 9.5 version, and this can be used to really understand how you can deploy your applications. So we have, at this point, we have 7 demos. We have a cutting stock, workforce assignment, resource matching, cell tower placement, offshore wind farming, facility location, and the TSP. And all those demos are deployed into the same cluster on Amazon, and for the optimization, it's using the cluster manager and the compute server and the web license service as well. So let me give you a little bit more details about how this is deployed on Amazon. So in the middle of this architecture slide, you have the Kubernetes cluster using EKS, and you have many containers. You have web app containers that will manage the web UI and the logic of the application. You also have the optimization workers that are using the Gurobi Pi API to build a model and submit the model to the cluster manager, and the compute servers will execute the optimization. The compute servers are entitled and use the Gurobi web license service to enable the use of Gurobi inside those containers. So how does it work? From the left, you have a web UI where you have your application that is running. Each application or each demo is different. And in front of our environment, we have a load balancer that will route the different demos to their web application containers. When you click optimize, let's say, in one of the demo, this will store the data into the database. It will also send a message to our queue, our Redis queue, and so that one of the optimization worker running and using Python will take the job, execute that optimization job, and return the results that then will be able, then you can display. So if you want to know more about all that, and of course you are welcome to contact us and contact our support. You can also read the documentation that we have. So each demo has a complete documentation about the architecture. We also explain how it has been deployed to the Kubernetes cluster on Amazon, and we explain the best practices on how to do that. So if you are interested, please take a look at this architecture page. And now I'd like to give a demo of the major features, and I will show you some of the demos that we have up and running. Okay, so to access the demo that we have, you just have to go to demos.gurobi.com. You need to be registered, but if you are not, you can create an account, and then you can continue to the demos. And you on the right, you have this button here, and you can switch between the different demos that we have. So we have seven demos that you can access to. And the structure of each demo is is always the same. You have this button, a live demo, that will give you access to the running demo. And you can also look at the getting started, which will introduce you to the demo. You have even sometimes a tutorial and explanation about the optimization model. And as I mentioned, also this page about the architecture, where we will review the different components and also how to deploy to Kubernetes, for example. So I'm not going to go through all the demos, of course. I will pick one that is the TSP as an example. And of course, you can look at that by yourself. So here, basically, you can play with this demo by, clicking on the different locations and where you want to stop, and then click on Optimize, and this will generate the solution and display the solution to you. You can also create different scenarios. So let's say I create another scenario where I have different data sets, and I can click on different data, and then I can say optimize, and this will optimize this specific data, and you can switch between different demos. So it is pretty convenient if you want to compare and understand how it is running. I will not go into the details of the demos themselves, but I want to explain how it works behind, and how the jobs are submitted, and how you can monitor what's going on. So when you click here on Optimize, a lot of things will happen. It will send, as I mentioned, an event to our Redis message queue, and then there will be a Python worker that will take that request, get the data, build a model, submit the model, and then the cluster it will connect to the cluster manager. The cluster manager will then run the optimization into one of the compute server nodes that is available. So all that is done, as you can see, pretty quickly. So now that you understand a little bit how the application is running, I want to show you what's going on behind that. And behind that, we have a cluster manager. This is the cluster manager that handles all the requests coming from all those demos. I'm logged in already. I'm a system administrator in this cluster manager, so I have access to all the panels. And some panels may not be available to you if you are not a system administrator. But here I can show you that we have two nodes running into, so two compute server nodes running in this cluster. You can look at you can check that the license is valid. You can I have nothing running right now, but or queued. But if there were jobs running or queued, you could see that here. You have the job limit, which is the maximum number of concurrent jobs running at the same time on each node. You can change that you can change that as a system administrator. You can check that the license status. You can have more details about the license. Here I'm using the web license service. And you can see that this is the right license because it's using this key web float CS, which is the short name or the name of this web license service license. And you can look at all the accounts also as a system administrator. So here, actually, we have connected this system to our LDAP. Our LDAP is running on Jump Cloud, which is a cloud provider that is compatible with LDAP protocol. And only the technical people at Gurobi have access to this server, and you may recognize some names. And by the way, if you want to go deeper into a demo of the cluster manager, you can schedule a demo with one of our technical account manager, and they will be happy to show all that to you. So let's go back to the jobs here. You can see that all the jobs that are being executed, and those are the latest TSP problems that were executed. I can look at the logs. So in the logs, I can see this job dashboard. I can look at the login details. Of course, here the chart is pretty simple, but you can look at all the information about each given job. So what I'm going to do now is run another job that is a little bit longer, and I will to that I will connect to the cluster manager from my laptop and run the job there. So first, what I have to do is go into the API keys section, and I'm going to create an API key. I can specify an application name, and I can and also a description. I can create an API key, as you can see, and I can then download the client license file. This client license file is file like this. This contains, of course, my secret API key, so I won't share that too much, but I will delete that just after the demo anyway. What I can do is submit a model to that. So the first thing is that I want to point the variable Gurobi license file to that file that I have downloaded. That's it. So again, as I explained, this license file contains all the communication and the connection parameters to my cluster manager. So that's it. I have nothing to do. And the GRB license file is known by all the Gurobi components. So now if I just run Gurobi CL, which is our command line tool to submit different models, and I have a model called Glass4 MPS that I can submit. If I do that, then you can see that it's up and running. And I'm getting the log here. And if I go to the job, I can see that job list. I can see that my name, because this time it's not a demo that I'm running anymore. It's something that I've submitted myself. You can see the demo application here, and that it has been submitted using the Gurobi CL. And here I can look at the log and the charts. But let me run it again so that I can show you live what it is about. I have one job running. I can go here, and you can see that the logs and the charts are being updated live. Once it's done, you can download the log. You can take a look at all the attributes of the model. You know it is a MIP. You have some statistics about the model and so on. All that is available here. And you can also look at the history. So once the jobs are completed, they are added to the history, and the history is stored into the database. You can access the logs over several days, all that into your cluster manager. In terms of usability, as you can see, we have those question mark icons. You can click on that, and this will open the right page of the user manual. You can also browse the user manual and go directly to the different sections and look at the release notes as well. Yeah, maybe one last thing I want to show you is our Gurobi organization page on Docker Hub. So if you are interested by using our images, you can come here, and you will have access to all the documentation. You have the different, let's say, the different tags that you have to use the right Python version. And in the different section, we are going to explain to you how to use those images, to build a custom image with it, or to use Docker, Docker Compose, and in some applicable images, we also describe more in details how to use Kubernetes. And I think we can start looking at the questions.
Yes, thanks, Michel, for this talk. So we have a number of questions from our users. So the first one is, are there any thoughts on Gurobi providing a licensing option that is on a pay-per-hour basis? So this allows user to spin up and spin down instances on an as-needed basis.
So here we have, to support that, we have a Gurobi Instant Cloud, our Gurobi Cloud offering. So if this is what you would like to know more about, this environment supports that. You can actually, I'm still sharing, so you can go into our products and you have what is called Gurobi Cloud, and you can read more about it. This is supported on Azure and on Amazon, and again, you will this will be the answer to that question.
Okay. So next question. Is it possible to perform concurrent Gurobi solves in a container with a WLS license?
So we have two types of licenses. We have the single-use license, which is a default one that will enable only one use of Gurobi inside a container. But you can discuss with our sales and technical account manager to understand that there is another option to open that up to have to be able to run multiple concurrent solves within one container.
So as a follow-up question from me, so for academics, the license will enable concurrent use, right?
That's correct. Yes, it is the default for academics.
Okay, thanks. Then another question. So is Gurobi available for use outside the US market? So this comes from a user in South Africa who is interested in using Gurobi in South and West Africa.
Yes, yes, it is available.
That was easy. Another question, can the WLS be used as a floating license independent from Docker and cloud providers on, say, a user's laptop?
Yes. So what is required is just a connection to our to the internet. So as long as you can access the services running by Gurobi, and then there will be a check. You know, you need to be authenticated. You need to have a license, and you can have containers running at the same time on your laptop, in the cloud. Doesn't matter.
Mm-hmm. Okay, thanks. Then a follow-up question regarding the instant cloud. So just to be sure, this is really payment by the hour. Can you say, or can you say a little bit more about the license conditions?
Yes. So you have different license types from silver to gold and platinum. This means that you have a different, depending on how much you are willing to pay upfront, you have a different hourly cost. And yes, it is an hourly cost. There is, however, every time you start a machine, there is a minimum charge of 30 minutes. But beyond that, it is per the hour.
Yeah, but there is this additional yearly cost, right, depending on the license type.
Mm-hmm. Correct.
Okay, thanks. And then last question that we have, but of course you can still submit additional questions. So how does Gurobi parallelize the solver?
I mean, it depends if you are talking about the solver. I mean, one job and how you can parallelize that? Maybe Toby, you can answer that. Or if you have
answered it in two steps, right? So
right, exactly.
About the compute server, and then I will talk about the
yes. So if you have different jobs at the same time, then the different jobs will be load balanced into your cluster. I mentioned that you have each node in the cluster has a job limit. This is a number of concurrent jobs that you can run on each node, and this can be changed depending on how many cores and you have on each machine, and how many the complexity of each job. So you have the first way to answer your question is that if it is about different jobs, then it is load balance and spread out into the cluster. And then for a specific solve.
Yeah, and if you are asking about using a parallel cores in a single machine to solve one problem faster, that is internally realized by threading. So for Linux, we are using the pthreads library, and for Windows, we use the operating system methods provided by Windows to spin up additional threads. And then, of course, the threads are communicating with each other through memory. And then one of the biggest challenges here is to make sure that even though you are using parallel threads, the overall algorithm will stay deterministic, in the sense that if you run the same thing with the same data the second time, then you would get exactly the same results, which is not so easy in parallel execution. And then we have a third answer to your question, which combines the two answers, which is that we also have an option to use parallelization across multiple machines to solve a single problem instance. So through the cluster manager and compute servers, you are able to say that you want to solve a particular problem instance on a set of machines. So for example, on one compute server and an additional 9 worker machines, so that 10 machines work together to solve a single problem. And this is also something that we provide, which we are calling the distributed MIP algorithm. Okay, next question, again about containers. So are containers available, manageable from Instant Cloud Manager?
Yes, I'm not sure to understand the question. So Instant Cloud is so I mean, there are different ways of using our tools. I'm not sure if this is the question, but for example, you can have also your own containers running anywhere, and you can use Instant Cloud. So I would say that one way of deploying into containers is that you have you can use your own containers, and using our new web license service, you can define your own environment, or you can also connect to Instant Cloud. And in that case, you will have more or less the same capabilities, but all the backend, I would say the cluster, the managing the machines, and so on, will be done by Instant Cloud.
I interpret this question like, so say you have your own container where you have installed stuff that you want to run. Can I pass that container to Instant Cloud, and then it will automatically be provisioned on AWS or Azure for me? Is that possible?
No, it's not. What Instant Cloud is providing is the equivalent of the cluster manager and the compute server. So it provides the backend optimization capabilities. If you have an application that you want to deploy and you have your own containers, then you need to deploy that into your own container environment. It could be, again, Amazon Kubernetes AKS, for example, EKS. And once you have that, then there will be a communication between your container and the Instant Cloud.
And can I control the Instant Cloud programmatically?
Yes. So you can
I don't need to go to the website manually every time.
Yeah, no. So you can, of course, yeah, you can. You have a REST API so that you can anything that actually, or more or less anything that you can do in the web user interface, you can also do it using the REST API that we provide.
Okay, thanks. I hope that this answers the question. So next question, can the Gurobi Docker containers be used in GitLab CI?
That's a good question. I think that I won't be able to answer that right now. This is, if maybe we can follow up on this one. In each environment, we need to make sure that this license service can be used, and this is one that we have to look at then.
So thanks again for your attention.